doesn't have any problem, then I'm going to start the recording for this lecture session. I believe you can hear me. Can you hear me clearly? Just someone
Yes,
confirm
sir.
me.
Crystal clear, sir.
That's good. Okay. So I'm starting the record. So actually, tomorrow we are going to appear the lab session exam. So I'm giving you some of the ideas so that you can have better idea on the lab session. The first experiment that you did in your lab that was named as uh, finding the equivalent circuit of a three-phase induction motor. Okay. In that experiment, what you did, you took a, uh, a three-phase induction motor. There, you measured the or you performed block flow test and free running test. So that means the no load test. And finally, you went for DC resistance test. Now here, uh, I believe all of you remember what you did in the lab because I already described about this lab in our theory class. Okay, right after mid semester exam. Now I'm going to show you some of the basic things. Uh, there, you saw you used a motor where we have a nameplate, something like this. There you found three this type of configuration, and another side this type of configuration was given. Okay, so this was the nameplate of that motor that you used in your case. I hope you remember. Now, here this is the stator side and this is the rotor side. As this configuration suggests that this rotor is squirrel cage type, and this is the stator. Stator has three windings. You can make it Y-connected winding. That means by making this three side short and giving supply to this side, three-phase supply. Now, in order to measure voltage uh, across the lines, so you placed a voltmeter, and in order to measure current, you placed an ammeter in series. Okay, you need to remember something. Well, there were also some nameplate value that its voltage rating was written here 380 or 220 voltage uh, Y or delta. What does it mean? Can anyone tell me? It means the rated voltage is 380 voltage if we have Y connection, that is line to line, and rated voltage will be 220 voltage if it is Dell connection, Dell connected configuration. You can make it Dell connected even. Uh, if we connect this wire, and this wire, then it will be Dell connected. So if we have Dell connected configuration in the stator side, the rated voltage will be 220 voltage. This is the rated voltage. And also the rated current rating was given current. Okay. Something like this 2.54 or 4 ampere Y or delta. That means if we have Y connection, then 2.54 is the maximum current, that means rated current, and uh, if we have Dell connection, we can go up to 4 ampere current. Okay, so this is the motor configuration. If I ask you this question, or I may ask many questions from this configuration that we have a Dell connection, so what is the maximum amount of current that we can provide through this wire? So you must say this is this should be 4 ampere current. Okay, and also you used different types of meters. For example, you used uh, ammeter like this, I think you remember. This is the ammeter. We have a needle. We have the marks here. Okay. And you saw we have three knobs here. On the knobs, it was written that it is 6 ampere, it is 3 ampere, and this is plus minus. That means, what does this 6 ampere mean and 3 ampere mean? Can anyone tell me? Any idea? This 6 ampere means if you connect through this line, this 6 ampere means from here to here, the maximum value is 6 ampere. Okay, so in between, if this needle crosses the half of the path, then it's 3 ampere. So in this way, you can divide the scale. But if you connect your ammeter from this line to 3 ampere and another line will go from here, that means from here to here, the maximum will be 3 ampere. So you can divide your scale accordingly. Okay. Suppose you want to measure 4 ampere current, 4 ampere current. And if you give connection your ammeter to this 3 ampere current and to this plus minus, that means maximum it can go up to 3 ampere current. So you will not be able to measure 4 ampere current. So connecting your ammeter in this fashion, actually that will not be the correct. Okay. So this type of questions will be asked, will be given the figure of different types of meters, and you need to connect those meters accordingly, correctly. Okay. Also, at the back side of this meter, we use a mirror. Why do we use a mirror? So that we can avoid the parallax error. Okay. Whenever we'll look on this needle, if you look from the side, that means you are not taking the correct value. So if you look from the top, then the reflection of this needle that will coincide on the mirror. Okay, so the parallax error can be avoided. Now, in the meantime, let me ask you if you have any question in between when I'm giving lecture, you may ask. Okay. Otherwise, I'll keep saying, uh, considering the fact that you do not have any question. Okay. So these are the fact. These
Sir,
are the yes.
what was the needle for? My network wasn't stable. I couldn't hear properly. The needle.
Actually, the needle will move to give you the correct, the corresponding value. Suppose here it's something like this. Okay. Just we have the scale, and suppose this is 0, this is 1, this is 2, and needle is on this line. That means it's showing 3 ampere current. That's it. You used to that, right? Uh, so what
Yes,
I
sir.
said, if you connect with 6 ampere, so it will be the maximum value will be 6 ampere. Okay. So from 0 to 6, you divide your scale accordingly. Okay. So that was my uh,
Yes,
uh,
sir.
uh, actually observation. Okay. So be very careful when you give connection. Okay. This type of connections you must draw. I'll give you these different types of ammeter figures in your exam paper. You must choose one correct ammeter to measure your current. Suppose 2.54 ampere. I am giving you one ammeter that has maximum value of 0.5 ampere. That means it's not capable of measuring 2.54 even. So if you choose that ammeter, that will be wrong decision. Okay. So when tomorrow you'll be asked to use an ammeter from different sets of ammeter, there will be a lot of figures. A lot of there you must choose the right ammeter. Okay. Okay. So that is it. And all other questions, I think, and you must know how to give connections of watt meter. The wattmeter connection configuration will be given to you. Just you need to give the right connection by seeing the connection configuration that is given on the backside of the wattmeter. Okay, that's it. Now, if you have a motor configuration like this, suppose the
Sir,
configuration is
sir,
yes,
sir, can you
yes.
show the wattmeter current configuration, please?
It depends on I mean the configuration given in the nameplate. Okay, suppose you have an wattmeter. There are a lot of buttons. Okay, and this is the buttons in typical configuration that is used in our lab. The configuration is shown in this fashion. Okay, so it is said that these 2 points will be shorted, and here one uh, power source. So your line will come. Suppose this is the motor and this is the power. So one of the positive and one of the neutral line will be taken. Okay, power source from the power source. Okay, so if you have the motor, so this motor, one of the phase connection will be there. So you must take one phase and one neutral. So one phase connection will be connected directly, and neutral connection will be taken from here, and that should be connected with this knob. Just make these two knobs shorted, and also one line will be connected. So this is the configuration you must understand. Suppose we have this motor, so one neutral connection, this n connection will be given to here. So take any of the phases, and in between you connect your wattmeter, and this neutral connection will be through this, as per this configuration that I showed here. Okay, so just place this to here. Okay, so and also if you have connections like this, okay, and you have connections like this and this, the other side are open. So this is stator, this is rotor. Can anyone tell me what type of motor is this by seeing the configuration? Well, you don't have to say.
It's an induction motor.
Induction motor. That is not the full answer. That is definitely correct. Induction motor. This
Three-phase
is
induction motor.
three-phase induction. Still, it's not full answer.
Squirrel cage.
Not squirrel cage. Squirrel cage was the previous one. This was the squirrel cage. You see,
This is
the
one
rotor.
Own rotor.
Yes, own
Own
rotor.
rotor.
It shows its own rotor. Okay. So by seeing this configuration, you must say own rotor. And other sides are open. That means here you can connect 3 resistance in the own rotor side sometimes and make it short. Without connecting resistance, you can make those shorted. Okay, both you can do. Either you can connect resistance or you can make this them short. So you can add external resistance to the rotor side. So this type of motor is on rotor test. Okay, and also if you are asked how did you take the DC resistance value, what we did, we connected this, and we place a multimeter to measure the resistance in between and divide it by 2 to get each resistance. And after getting this resistance, what we did, we multiplied 1.25 with the resistance in order to get AC resistance. That was the thing we did. Okay, and then we connected some load with the motor. Well, block rotor test and no load test. No load test means the motor was running freely. Block rotor test means we blocked the rotor. Okay, so in general, if you are asked that what you mean by full load of a motor, I told you this thing several times in the class. Full load of a motor means when the motor starts taking rated current, and then it is called full loading condition. Okay, rated current. And block rotor is not full load. Block rotor is considered as the short circuit condition. That is, it is heavily loaded. Okay, so when you will answer the question, try to answer the question in a way that you did in the lab. Okay, there will be a lot of questions, small question. Write or answer the question within one sentence or few words. Okay, do not write much. Just be very precise while answering your questions. Okay. Yes.
Sir, could you
Can,
please
can you
repeat
please
the-
come again? Can you please repeat what you just said?
I said that there will be a lot of questions. While answering the questions, you don't have to write much. Just use only one sentence or few words to answer the question. Be very particular when you answer the question. Okay.
I mean the portion where you say when you ask us what is full load and what is, I don't know, block load.
Oh, what is
that
full load?
portion.
Full load means when a motor starts taking rated current, the amount of load for which motor starts taking rated current, that is called full load. Okay. Block rotor is not full load. Block rotor is highly loaded, short circuit test. Okay, that is, you are not allowing the motor to rotate. That is beyond full load condition. Okay.
repeat the DC resistance?
That was described in the class, because when we have a wire and current starts flowing, for DC current, the current is distributed throughout the wire. But for AC current, the current tends to move in the surface areas, okay, due to skin effect. And that's why the effective area becomes less for AC current, okay. So if effective area becomes less, then the resistance becomes higher, okay, because if this cross-sectional area is reduced, then the resistance will be higher. So for DC resistance, when the value you will get, you must multiply with that 1.25. It was found practically that if you multiply 1.25, then you'll get AC resistance, which is higher than the DC resistance. Okay. So that's it for first experiment. Just answer the questions the way you did in the experiment. Now, for the first
Excuse me, sir,
experiment, you didn't have to learn those that the theory part where you figured out all the values for equivalent circuit. You don't have to learn those things. Okay. The thing you need to remember that what you did in the lab. Okay, how did you place the voltmeter? How did you connected the ammeter? How did you connected the wattmeter? How did you take the valve? How did and what type of ammeter you used? Okay. Okay. Any other question? No. Let's see. Let's proceed. Okay. The
Sir.
next. Yes.
স্যার তাহলে কি ফার্স্ট এক্সপেরিমেন্টে যে কিছু ক্যালকুলেশন ছিল কিভাবে বের করছিলাম ওইটা দেখা লাগবে না মানে
No,
মনে
no,
রাখা
no,
লাগবে না?
no, no. You don't have to go for the calculations. For the calculations that used to measure the equivalent circuit parameters. Those are very tiresome calculations. I'm not going to give in any calculations, okay, or any complicated calculations in tomorrow's exam. Rather, I'm going to focus whether you understood the lab correctly or not, whether you are capable of using the correct ammeter, correct voltmeter for your certain purpose or not. Okay,
ওকে স্যার
so focus on that part. Next, we did torque speed characteristics of a three-phase induction motor. Okay, so in this case, we took a three-phase induction motor and connected with one load. This is artificial load. Okay, artificial load. That means it will try to hinder the motor to rotate. Here we gave three-phase supply, and in order to measure voltage, we connected the voltmeter, and in order to measure current, we connected one ammeter. Okay, So what type of voltage is this? This is line to line voltage. Okay, so line to neutral voltage will be divide whatever value you'll get divided by √3. That will give you line to neutral voltage. Okay, remember this thing. Now, if you increase load, what will happen to the speed? Speed will decrease, and you saw it is decreased. If you increase load, what will happen to the current? You saw, suppose this is current and this is torque, load torque. So if you increase load torque, current will decrease. Okay, something like this. And I think you measured those values. Okay. And also, suppose torque versus speed, NR versus tower. If you increase tower, then speed decreases. And if you decrease tower, so if you plot this, you plotted this, you got this type of curve. Okay. Now, practically, your curve looks like this, but in theoretically, and practically you got the red part. Okay, because practically you cannot measure these values in unstable region. Only you measure the values in the stable region by changing different torque and loads. Okay, so these are the things you did. So again, similarly, you must remember what type of ammeter you use here. AC or DC, you must know. Okay, you are giving what type of supply, you know. So corresponding ammeter you used. So you must remember, or you must know what type of ammeter you used here, and what should be the maximum range of that ammeter. If the nameplate value of this motor is given, you know, you should know what should be the maximum range of that ammeter. Okay. Anyone has any doubt that what type of ammeter should you use?
So type of ammeter means the rating of ammeter or anything else?
Rating and AC or DC. Suppose I'll give you several ammeters. Okay, 4 ammeters will be there. So this is DC, and this has a maximum range of, for example, 1 ampere. This is 1 ampere neutral, and this is 0.5 ampere. But here the rated current is suppose 2.54 ampere. So this ammeter won't work, because this is using this ammeter you can measure maximum 1 ampere. Here for rated current you may need to measure 2.54 ampere. So if you choose this ammeter, that will not be the correct choice. So what you need to do, you need to check another ammeter. Okay, and also this is DC. So you choose the AC ammeter part, because here the supply that you are giving, that is AC supply. Okay, so you must choose the right ammeter. Okay, I believe you will be able to choose the right ammeter. Okay, these are the main thing you need to suppose the next experiment that you did. Let's tell you how can I add the new page. Okay, suppose the next experiment was V curve. Okay, V curve, that was your open-ended lab. Okay, in V curve, what did you use? You used a synchronous motor. In synchronous motor, the nameplate will look like this. Here there will be 3 windings for stator. This is the stator, and in the rotor side, there will be squirrel cage. Also, there will be option for giving DC supply. Okay, this is rotor. I believe you remember. Okay, and here this same thing can be used as alternator, that means generator and also motor. When we'll be using it, motor will give supply to the system, 3-phase supply. Okay, and make this short, this will become Y connected, and their stator rated current will be given, and also rotor rated current will be given. So rotor rated current will be DC, stator rated current will be AC, because in the rotor side we provide DC supply. Okay, so you must suppose I'm asking you what is the maximum current you are giving in the experiment while performing this experiment, you must give DC supply from a DC source, and here you must use an ammeter, and that ammeter should be DC ammeter. So there will be DC ammeter present, AC ammeter present. While connecting this, you take this to this DC ammeter, sorry, from here to here, and give this connection. Okay, you must give the correct connection to the correct ammeter. Also, to measure the current of this stator side, you must give connection to the AC ammeter. Okay, so this is AC ammeter, this is DC ammeter. Also, you must choose the right ammeter having the right range. Okay, maximum right range. So be very careful when you give connection to ammeter and voltmeter. Okay, and in V curve, what you did, you took the field current IF. Also, here this field current is DC, and you measured the stator current IS. So for small field current, you got this IS, so it was reducing. So it looks like this. Okay. For another IF current, you got this. Another, I mean, this one is for higher load. Okay, giving more load. This is less load. In this way, you plotted this V curve. If you understand this part and giving how you give connection, that will be enough to answer the question. Okay. So be very careful when you answer the question. Try to remember what you saw. Suppose if you are asked that in synchronous motor, how many slip rings were there in the rotor side? In the rotor side, we have only 2 slip rings. One is to give this DC supply, positive and negative, and from here these connections are taken. And in on rotor induction motor, how many slip rings were there? There
3.
you saw 3. Actually, practically in our lab there were 4, because 2 are sold in a set. Okay, so but 3 were in use. Okay, one was left without any connection. So 3 were in use. So if you say 3, that will be also the correct answer. But for synchronous motor, you saw that there are only 2 slip rings. Okay, these observations you must remember. Okay, and if you are asked that what was the process of starting your synchronous motor, what did you do? Did you give the DC supply right from the beginning? No. What you did, you gave 3-phase AC supply. Okay, and this DC supply was switched off. Okay, this DC supply was switched off. Then this motor will start running as induction motor. Okay, then when their relative speed, the relative speed between RMF and relative speed between RMF and the rotor will become low. Then you provide DC supply so that they can be interlocked very easily. That I told you in that class as well. So in the lab, you also followed this method. First, you gave AC supply, 3-phase AC supply, motor will and make sure that your DC supply is disconnected. Give AC supply, start running your rotor as induction motor, then provide DC supply. Then it will start running as synchronous motor. Okay. Any question up to this much? No. Okay. Do you think answering this question will be tough? I believe you'll enjoy the exam. Okay.
Well, sir.
Do not feel any pressure. Do not feel any peer pressure. You just keep answering the questions. Answer as many questions as possible. Okay. I'm putting a lot of questions so that even though you fail to answer some of the questions, there will be a lot of questions which you will be able to answer. Okay, nothing to be worried.
স্যার
Okay.
স্টার্টিংটা আবার একটু বলতেন
Starting. How to start a okay. how to start a synchronous motor. Okay, how many supplies are there? One is AC supply, three-phase AC supply, another is DC supply that is given to the rotor. Okay, so before you provide this DC supply, make sure that this DC supply is switched off. So it is switched off. Okay, so you give AC supply to the stator. What will happen when you give AC supply to the stator? There will be rotating magnetic field, and as we have squirrel cage configuration here, the rotor will start rotating like induction motor. So when rotor starts rotating like induction motor, their relative speed between the RMF and rotor will become low. So then you give, when it gains some speed, then you provide DC supply. Then this RMF and the rotor windings, magnet will be interlocked together and they will be moving together. Let me show you the figure that I drew, I think hundreds of times in the class. This is the RMF. Okay, it's rotating, and this is the rotor DC supply. Okay, so when they will be interlocked and they will be moving together, but that is not possible at the beginning. So you start rotating the rotor with as a induction motor. Then when the rotor will gain some speed, you give the DC supply. In a nutshell, I repeat, first of all, you make switch off the DC supply, then give three-phase AC supply, then motor will start running as induction motor, then switch on the DC supply. This is the complete process. Okay. And when you will draw this V curve, you know, I showed you in the theory class, just see this theory. This portion is inductive region. Okay, and when we have resistive region, this point, and this is the capacitive region. You know this. Okay. One thing I need to tell you, in some of the section I told you that you don't have to submit your lab report, but some of the students, they I think your lab teacher, they told me that some of the students they already completed their lab reports. So your lab teachers want me to tell you that you need to submit your lab reports. Okay, so as some of you did it, so that will not be a good thing not to submit the lab reports. So you try to submit the lab reports as some of you requested. Okay. Anyway, let's go.
Sir, since you had already told about not submitting the lab reports, many of us haven't done it in the last few days. So doing it in the last 2 days would be too much pressure for us. And we have two projects to submit in the next 2 days.
It's not from our side, it's from your side. Okay. I
Sir,
personally, I personally.
Optional that those who have completed, let them complete, and those who haven't.
No. If it is submitted, that will be evaluated. Okay, definitely.
So then can't you manage not to submit that?
Sir, with so many things, how we will be evaluated? Sir, with so many things in this course.
You will be evaluated nicely, inshallah. Okay, you don't have to be worried about that. So as a good number of students, they are requesting, your lab teachers, they also asked, requested me to resume the submission.
Sir, as per our knowledge, I guess no student requested to evaluate the lab report. I mean, no one had
you don't know. That's out of your knowledge. Okay, you don't know who meet whom. Okay, your lab teachers, they talk to me, and they said that as some of them did it, they may submit. Okay. As per your knowledge,
sir, but
no one
many of
requested.
us haven't done it, and it will be very tiresome to do it within 2 days.
Yes, it's none of you, I think, from section C, but I don't know anything about the other sections. Anyway, let's see let's cover up our this lecture. Okay, That is, keep that apart. Okay. Anyway, so where were we? We already covered 3 of the labs. Okay. Let me share one more thing. OCC and SCC curve. Okay. OCC and SCC curve. You remember OCC and SCC, open circuit characteristics and short circuit characteristics of a synchronous generator. So this is the case. So if this is the case, OCC and SCC. Regarding the lab report, you talk to your lab teacher. Okay, their decision will be final. I am not going to interfere on that issue. Okay, OCC and SCC of a synchronous generator. So you remember our this is DC supply and this is PA, this is generator. If we ignore the resistance part, this is called characteristics impedance of the generator. We need to figure out the value of this excess. Okay, how to do that? In order to do that, you must know suppose if it is short circuited. So if you know the current, then what will be the value of excess? Excess will be equal to EA over IA. Okay, but it's impossible to measure the value of EA because this is internal voltage. We can measure the voltage value here, terminal voltage, but it's impossible to measure the value of EA. For that case, we go for this test, OCC and SCC, for certain amount of field current. What we do in OCC case, we take EA and make this side open, and it starts increasing the DC supply. If we increase DC supply, EA will be increased. As it is open circuit, no current will flow. So whatever voltage you will get in the terminal side, that is equal to EA. Right? This VT will be equal to EA because no voltage will be dropped here as no current flows through and this under the open circuit condition. So here, what we are going to do, we'll keep increasing the value of field current and we'll measure the value of terminal voltage, which is actually equal to EA. So terminal voltage, if we increase field current, terminal voltage will be increased in this fashion. After some times, it will go to the saturation condition. Okay, this is one of the part in the experiment. Next part, what you are going to do, you will make it shorted. When you'll make it shorted, huge current will flow. So you put an emitter here, and you see start increasing the field current similarly, and take the value of this current, emitter current, that is IA current, or we name it I short current. So for very small amount of increment of field current, huge current will start flowing. So when are you going to stop increasing field current? When you see that the rated current starts flow through this line. So you will just draw another line that will give you the rated current. Okay. So for any value of field current, you check the value of EA and check the value of IA. Put the value of EA here and put the value of IA here. That will give you the value of excess. Okay, for any case. So you'll see that there are two parts. One is linear, another is non-linear. Okay, linear region, that is called unsaturated, and this is the saturated portion. So if you take the values in the saturated region, that means EA over IS, then that will be called saturated synchronous reactance. If you take the value here or here in the linear region, that will be called unsaturated synchronous reactance. This is how we perform this experiment.
So
Now
can you
here,
explain the short circuit part again?
short circuit part, what we
Uh.
do, we take the generator and the output terminal, we make it shorted. Okay. In your experimental case, what you did, here you have the 3-phase. Okay. Okay. Here you have 3-phase. Here you have the field. Okay. You gave the field supply. Okay. The output sides are made shorted. If you make it short, then you start rotating this generator. Then this field will cut this generator winding, and this, due to the internal voltage, small amount of field voltage or field current, there will be huge amount of current flowing as it's short circuited. Okay, huge amount of current will be flowing through this ammeter. Okay, so when you will start increasing field current here, suppose the 0 voltage, nothing will happen. 1 voltage, some current will flow. 2 voltage, okay, so 2 volt in 2 volt DC, that will give more current. So you keep increasing your field current in a way up to that value when it will start flowing the rated current. Okay, rated current. When it starts flowing the rated current, you stop and take all the values here. Okay, you'll get a straight line. Okay. So in this way, you measure the value of synchronous reactance. Just take EA divided by IA. Okay. So that's it for open circuit test and short circuit test. Okay. And finally, you performed one lab, that is parallel operation. Do you remember that parallel operation? Okay. In parallel operation, what you did, you had infinite bus and you connected your generator with infinite bus. Okay. We showed these things in the class. Okay. Here I'm giving you some letting you know some critical point. First of all, your generator was run by in the lab using DC motor. Do you remember? Using DC motor. It was coupled with this DC motor. DC shunt motor. Okay. So you remember how did you increase or decrease the speed of this DC motor? Can anyone remember? Okay, you change the field, right? That is the answer. Okay, and also, how did you set the alternator's output voltage exactly same? Suppose here you got some voltage. Here you were measuring the voltage. Suppose if this voltage was less than this voltage, so how did you set it? No, the voltage was increased by increasing the excitation of the generator. Okay, excitation. There was a DC supply to the generator, right? There was a DC supply to the generator. DC supply was given to where? Stator or in the rotor side?
The rotor side.
Rotor side. That is called excitation. By changing excitation, if you reduce excitation, terminal voltage will be reduced. If you increase excitation, terminal voltage will be increased. So you keep increasing excitation up to the voltage level when it matches with exactly same as the our incoming voltage. Okay, do not forget that. And
So can you repeat this part again?
what we said that here voltage, okay, and here another voltage, they are not matching. So suppose this voltage is higher, you need to increase this voltage before giving the connection. In our generator, we have DC this was run by DC motor, and here in the rotor side we need to give DC excitation. If you increase excitation, the terminal voltage increases, VT increases. So you keep increasing excitation and VT will be increased, VT will be increased. You keep increasing up to that value of VT when VT matches with this voltage. Okay, this is how we matched our voltage. Okay, so that's it. Then you went for 3-lamp method. There you connected 3-lamp method. Suppose 3 lamps are switching on and off, but not at the same time. What does it mean? It means that phase sequence are not correct. Phase sequence are not correct. So what is the remedy? Just change any 2 phase of connection. Then you will see that all the 3 lamps are switching on and off at the same time, which implies that our phase sequences are correct. Okay, that description I gave in the theory class as well. Also, we took the frequency of the new generator a bit higher, not exactly same. Can anyone tell me why should we take the frequency of the new generator a bit higher, not exactly same?
So that the phase angle can match
Short or
later on.
Yes, this is one of the reasons. Another reason,
So that
Does it become
it doesn't become a
float
load for the
online?
infinite pulse.
huh? I didn't get you. Answer again. I can't hear anyone. Are you talking?
So that it doesn't remain in a float online condition where it doesn't give or take.
Yes, float online, or it doesn't. If you take a bit lower frequency, then it will act as a load. Okay, so we want right after connecting, we want to contribute. That's why you need to take the frequency a bit higher. Okay, so more or less that's all. Just whatever I said. If you remember these things, then your exam will be fine. Okay, nothing to be worried. Take good and just you keep remember or keep discussing with among yourself what you did in the lab. That we in this lab we took an emitter, this thing, that thing, and we connected that way. And in the rated voltage condition, under block rotor case, we did not supply give rated voltage. We provided rated current. Sorry, in block rotor case, we considered the rated current, and under no load condition, we provided the rated voltage. Okay, because that was under no load condition. So just keep try to remember all these things. Okay,
Sir.
that will be enough. Yes.
Sir, apart from these experimental setups and connections, we also needed some theoretical knowledge to write the report questions in the lab report. So, will those be necessary for tomorrow's lab quiz? Will there be
It's
any
better.
questions?
It's better if you have discussion on those questions. Just discuss among yourselves. Do not just memorize those questions or the answers of those questions. You discuss among
Sir,
yourselves.
will most of the questions come from these connection diagrams and
Yes,
equipment?
most of the questions will come from the connection and diagram. Okay.
Okay.
Okay. Any other question?
Sir, I have one question from the last lab, sir. What is meant by motoring of alternator, sir? Motoring of alternator. Can you explain it, sir?
What is meant by
The motoring of alternators.
motoring? I'm
Of
not getting
alternator.
you.
So motoring of alternator.
Motoring of
Alternator or generator, basically, sir.
alternator, generator,
Yes, sir.
motoring.
Yes, sir. Yes, sir.
The motoring means that generator will act as motor. That means partial motor. I showed you in the class. Suppose we have infinite bus. Okay, and this is your generator. If under if it is not connected, when it is not connected, if the frequency is higher, then after giving connection, this will be the contribution of your generator, right? But if your generator is connected with a bit lower frequency, that this will be the case. Okay, so what will be the operating point? This will be the operating point. Now this side is the contribution of your generator, and this side is the load or power consumed by your generator from the infinite bus system. This will be the operating point, same frequency, but it's acting as partial motor. Okay, so that is called motoring of a generator. That means your generator is running as motor, partial motor. Instead of giving power or contribute power to the system, it's taking this amount of power from the system. Okay. Have you got it?
Yes, sir.
Acha. So, any other question? No, if you do not have any other question, I want all of you to go through this concept. You don't have to take too much pressure. Just remember what I said and just try to have very good discussion, healthy discussion among yourself, what you did in the labs. Okay, that will be enough. So up to this much today. Thank you very much for joining the session. I wish you good luck.